Hello?
Yes, please.
Yeah, okay. So first of all, I wish to thank the organizer for inviting me to this such an interesting panel discussion, especially Dr. Pratima Singh. So the topic of this India Clean Air Summit, looking air pollution through climate science, it is very interesting. At the same time, this session, better data for better policies, standardizing measurement practices, which is obviously very important to means whether we are doing in air quality or climate change, we have to have good data. And I think I'm the last batsman of this session, and probably I am the one which is sitting between you and your coffee. So I will not take much time. So let us start. So first, this is another part of the today's theme, that what are the challenges in measuring ground-based air pollution. Let me add here, means I will echo most of the other panelists what they already talked about, Professor Day or Dr. Tiwari or Dr. Ghosh and all. Probably in a different way, but I will be telling most of the things similar. You may find something new also, but let us see. So first thing is, there are thousands of species in the air, we know. So what to measure when we are talking about challenges? And for that, now since 1 or 2 decades, people talk about criteria pollutants. So for air quality, they say these are the 7 criteria pollutants, like sulfur dioxide, NOx, CO, lead, PM10 or PM2.5, VOCs, volatile organic carbon, and ozone. And they consider, if you are measuring them, that means you are talking about air quality. For bigger monitoring network, it is fine, but if you want to have comprehensive physical, chemical and optical measurement, which are required for the climate research as well as for the air quality research, you need a huge set of sophisticated and expensive instrumentation, which is very essential, at least for a few sites. We can't, obviously we can't put all over the place, but we need that. Why do we need that? Because when we are talking about air quality, physical means you are talking about the, say for example, you are talking about particle size. So size will decide how deep it can go in your body. Then composition means you will tell that what species we are talking about. So that species will decide that how toxic it can be. If it is simply salt, it will not affect. If it is lead or arsenic or something, it can affect very seriously. So you have to know what is the physical, chemical and optical properties of those things. And then strategic site selection. That is another very important part, because putting the sensor or instrumentation anywhere will not work. You have to put it in a proper way. You see the topography, you see the wind patterns, and then you have to put at the places which is actually representative of the given region. And then obviously skilled manpower. So if you are doing measurement, you have to have a skilled manpower which can actually produce quality data and then process it properly. And then, as many of our panelists were also talking about, we have to do collaborations. So air quality, people are doing, let them do. Climate change, let them do. At the same time, if you share the data with the epidemiologist, they can relate with the people who are getting admitted in the hospital, and then they will come up with something else. Or if we give the data to the modeler, for example, Dr. Akshay was talking about, if you give the data, then means you will have better utilization of the data what we are collecting. Now let me tell you some points to be considered. These are maybe, for some it can be very simple thing, but for some it may be interesting thing. So whenever you are doing ground-based measurement, I am telling you very specifically, then some points we have to take care. For example, position of sample inlet, where you are putting the inlet. Say you give the same instrument to 5 people, the same place, and if they are not measuring properly, they will come up with the 5 different data set. So there has to be standardization of that. So position of sample, distance from the source, how far you should keep the inlet. Then other people also talked about calibration and validation of sensor or whatever instrument you are using is very important. And then semi-volatile secondary air soil. What is that? I will be talking partially about all these things. Say for example, air sample inlet. When we are talking about climate research, it should be at least 3 meters above the ground level. And there should be free flow of air from all the sides. Suppose if you are at some place like which is shown in this slide, like in some rural place if you are, then you don't have any terrace or something, then you can make some kind of a structure or tower and you have to put this on there. Somebody may ask, what is the harm if you are putting it at the ground? Means why you have to hang it at 3 meters or 5 meters above the ground? Because if you are not doing this, then you may be affecting your sample by the local suspended dust in the surrounding of your sampler. So that is why it has to be high enough. But if you are talking about health research, then the inlet should be 1.5 meter. Now why is it so? Because 1.5 meter, it is close to the height of our nose, and we are inhaling the air from this height, so that is why this height is good for if we are doing health research. However, these heights should not be taken as a fixed rule. If it is for climate research, it has to be 3 meter or it has to be 1.5 meter. Whomsoever is there, researcher, they need to assess the ambience also and then select accordingly. Then other thing, distance from the source. Now sample inlet shall be sufficiently away from source depending upon the source system. So what do I mean by source or source system? Say for example, wood burning is a source, but you can just burn one block, or you are burning the whole forest. So that is, wood burning is source, whether it is block or forest, that is source system. So we have to make sure that our inlet, it is not in a close proximity, and it should not be, you are not sampling from the plume which is coming from the source. Say for example, if you are doing some more mobile measurement and you are going in the traffic, and if you put the inlet at the exhaust of truck which is going ahead of you, obviously you are going to get very different result. What you should do, that you put your inlet at such a place where you are actually sampling the mixed air from whatever sources are there in the surrounding. And then this is the most important thing, sampler must be calibrated and validated. I just took an example of dust track. Dust track is an instrument which is 2.5, and I took the figure from recent literatures. What you see here, this is stationary reference element, then dust track 1, dust track 2. At the same place they are running, and you can see the difference in the concentration. But once they are calibrated and put properly calibrated, post calibration, you can see they are all matching. This is what it should be. Then validation, dust track versus gravimetric method. You see, ideally all the data points should fall on this 1:1 line, but if the slope is about 2, here the slope is about 0.8. That means it is overestimating or underestimating. So for PM 2.5, I am just giving this as an example. It is applicable to any instrument we are using. So this PM 2.5 measurement by dust track monitors can be biased as their response depends upon humidity, particle size and composition. So appropriate correction factor for a given environment is needed. And then semi-volatile secondary aerosol. So probably we all know what is primary or secondary aerosol. Primary aerosol means which are coming as a particle in the atmosphere. Secondary means which are forming in the atmosphere from the gases. So there are particles in the atmosphere, we know, and there are many gases, SOx, NOx, VOC, ammonia, all these are there. They react with each other and form secondary particles. But if they are forming particle like ammonium sulfate, which is quite stable, if it is formed, it will remain like ammonium sulfate. But if it is forming ammonium nitrate or secondary organic aerosol, then depending upon temperature and humidity, it can go back to the gas phase. So if we are doing measurement, secondary aerosol, which are semi-volatile, they are highly variable and they change dynamically. So we have to make sure that wherever we are keeping the inlet, for example, if you are sitting in some building with a concrete wall and you are putting the inlet just outside of that, we know concrete wall heats in a different way. So it will change the temperature and humidity in the surrounding, so which can affect the secondary aerosol. So we have to be careful about that. Then we need, overall what I am saying, that we need a robust ground-based measurement network which shall be a combination of campaign mode and continuous monitoring station. Continuous, as many people were talking about. At the same time, we should also do some campaign mode. Say some biomass burning is there, so you make a campaign and then you see that if you are from biomass burning, if you are going away, how the things are changing, or in the surrounding, how the things are changing. And then say for example, you have stationary low cost sensor or mobile. You can put it on the car or cycle or wherever, and then government operated. Here it is written government operated. Whomsoever is operating, we are talking about the sophisticated instrument which should be there, which are measuring physical, chemical and optical properties. At the same time, as our previous panels also talked about, we also need satellite measurement for better identification of major pollution sources on regional and global scale, and for their understanding for their long range transport. When I talk about satellite measurement, let me add one more thing here, that most of the satellites which are there at present are polar satellite. Means they are passing a given region only once or twice in a day. And what we need is geostationary. That means it will move along with you wherever. Say if we are talking about India, it will move with India. So as we see what people are working on, constellation of geostationary air quality satellites in northern hemisphere. This GEMS by South Korea, it is already there. GEMS is Geostationary Environment Monitoring Spectrometer, which was launched in February 2020. This TEMPO, which is coming, TEMPO is Tropospheric Emission Monitoring of Pollution, which is launching in 2022, and the European Space Agency, they are launching Sentinel-4 in next year. So, and whatever you see, this square or rectangle, what you see, they are all field of view of those satellites. So they are continuously monitoring this region and moving along with this region. So 24 hours you are monitoring the place. But they cannot be replacement of ground-based measurement. Ground-based or satellite-based measurements are complementary. Street level things you can't measure through satellite. So overall, if you have both, then what we can talk about is we will see the comprehensive picture of air quality monitoring and also desired inputs. It will give desired inputs for mitigation policies. So overall, to summarize, as I said, sample net should be placed properly in terms of height or proximity of sources. Sensor must be well calibrated and validated, and it should be done periodically. It is not that once you have done and then you left. It has to be done periodically. Secondly, aerosol formation, it should be considered. Satellite measurement shall be validated with respect to ground-based measurement, and geostationary satellites are the need of the hour for air quality measurements. Ground-based and satellite-based measurements are complementary and provide comprehensive picture of regional air quality for making better mitigation strategies. Slightly deviating from the topic of this session, means involving common people also in mitigation strategies would provide better results. With this, I wish to thank you all, and if there are questions, I will be happy.